All right, so at this point, we're going to start talking about how the structure of a substance determines its properties. So as we move into talking about how structure affects the properties of a substance, I want you to think about something. So why are some things in our world gases, some are liquids, some are solids, even though they're all the same temperature? For example, right now, I'm sitting in my classroom, and my coffee is definitely a liquid at room temperature because it's been sitting here all day, so it's already cooled off, so it's at room temperature. The desk, however, are solids, but I'm sitting here breathing a gas. So why is that? Why is a gas all spread out and liquids are able to slide past each other like in my coffee, but my desk are solids and all the particles are really packed together and they have no movement. They can't translate past one another. So why is that? The answer is it's all about the structure of the substance and how strong the interactions are between particles. Okay, so if there's a really, really strong interaction, they get really stuck together, so they become solid. If they have less interaction, then they might be able to slide past one another, like in liquids. And then if they have no interactions, then they're bouncing all over the place like a gas. So the strongest interactions are occurring at the solids that are in my room, whereas the weakest is the air that I'm breathing. All right, so we're going to start by talking about the structure of ionic bonds, and they form these things called lattices. So we're going to talk about ionic lattices. So ionic bonding is the result of an attraction between two oppositely charged ions. So you've got a positive and you've got a negative, and they pack close together in a crystal lattice. So here you see some pictures of some example crystal lattices. This one is one that, a compound that you're more familiar with, NaCl, so this is just table salt. And then this one's just a generic one, okay? So what we actually have you write is the empirical formula, basically, or the simplified, just the ratio between the two ions in the lattice. However, this is how they actually structure together in the real world. Remember that ionic bonding occurs because you have one element that's giving up its electrons to another element. So one is losing, another is gaining, and you end up with a completely positive and negative. So you end up with completely opposite charges, and we know that opposites attract. So that's what's giving the strength to an ionic lattice. The cations and anions in the lattice are arranged in this big 3D thing that basically allows for every single positive atom to be surrounded by only negative atoms and every negative atom to only be surrounded by positive ones. This basically helps to maximize the attractive forces between the oppositely charged atoms and or ions. I keep saying atoms. Ions, charged atoms, so ions. And it minimizes the repulsion. So it's trying to keep those like charges as far away from each other as possible. All right, and here's just one more example of what the lattice looks like for ionic. So the green are the Cl minuses, and the purples are the Na pluses, and then you see that they like get together in this huge crystal, and that's how they arrange themselves. All right, here are some examples of ionic solids. Hopefully at this point in the unit, you know that it's a metal and a nonmetal, or a positive and a negative ion. It can include polyatomic ions, like these, okay? But those are all examples of ionic solids. All right, so what are the properties of ionic solids? So properties are that they are brittle, they have a high melting point and boiling point, they dissolve in water, and they conduct electricity as a liquid, as aqueous. Aqueous means dissolved in water, and as a gas. So in any of these three states, they conduct electricity. All right, so we talked at the very beginning of this podcast that everything, all the properties are related to the structure. So the first property that we're going to talk about is the fact that ionic solids have low vapor pressure. Okay, well, what the heck is vapor pressure? Vapor pressure is the pressure exerted by the gases in the system. So, all right, so go with me here. All right, so let's pretend this is a beaker. I know, my drawing's awful. And there is some substance inside this beaker, and we put it in this big bell jar, which has nothing else in it. We've pulled all the molecules out, so it's like a vacuum. And we put this liquid substance in there, or it could be a solid. That could be one too. And it starts to evaporate. Okay? All right, so as it evaporates, you have these little gas molecules, right? And they are bouncing around, and they're hitting the container walls. And the force that they exert on the container walls is the pressure. So basically, vapor pressure is the force exerted by the gas molecules, okay? So ionic solids have low vapor pressure. What that means is that they do not make a lot of gas particles, right? Well, hopefully that makes sense, because ionic solids are positive and negative things, and then they're attracted to each other, right? So that strong interaction between the positive and negative in that lattice keeps them held together. And so because they're held together, they don't evaporate very easily, so they have a very low vapor pressure. All right, another property of ionic solids is the fact that they are what we call brittle. Okay, so brittle means that they break apart real easy, okay? So hopefully this makes sense, because when they're brittle, the particles would have to slide past one another, okay? So if it's malleable, when we slide it past it, it stays together. But with ionics, when you make it slide past one another, you go from this very stable positive, negative, to now you have like charges, so positive, positive, negative, negative, positive, positive, that are repelling each other, and so because they repel each other, it breaks apart really easy. So that's why it's brittle. All right, another property of ionic solids is that ionic solids themselves do not conduct electricity. All right, so for something to be able to conduct electricity, the ions, or the charged substances within it, have to be able to move about. In an ionic solid, they are packed together, right? So, you know, then we got the positive, negative, you know, and they're all packed together really tight. And so because they're packed together really tight, they can't move. There's no movement. So because there's no movement, they cannot conduct electricity as a solid. However, when they are dissolved in water, they can conduct electricity. The reason that they can conduct electricity in water is because when you put an ionic substance in water, it breaks back into its positive and negative ions, okay? So let's pretend that we had, you know, some salts, right? I'm going to throw NaCl salts into water, okay? It actually will break back into Na plus and Cl minuses. So you'll have a bunch of Na plus, Cl minus ions just floating around in the water. So because the ions can move about, electricity can be conducted. You can conduct electricity through that solution. You can conduct it through an ionic solution, so an ionic solid that has been dissolved in water. So this is a test that people, scientists will do a lot of times to see if something is ionic, is they'll throw it in water and see if it conducts electricity. And here's just another picture, probably a little better picture, but you see that as a solid, you have all these little positive and negative ions, right? And when we throw it in water, they separate back into their positive and negatives, and they can move about, okay? So water itself can't conduct electricity because it doesn't have any positive and negative ions to move about. But once you throw some salt in there, it can move about, and so now it can conduct electricity.